There is another problem. This is actually the application of differentiation in one-dimensional motion. This problem actually leads to the application of differentiation in one-dimensional motion. So try to understand how the differential calculus is applied in one-dimensional motion. Okay. So this is for beginners. Okay. The equation of motion is x equal to a plus bt square. This is a one-dimensional motion. The object is moving along x-axis. Therefore, its position at any time is given by x. X is equal to a plus bt square, where a as a constant is 5 meter and b is 10 meter per second square. So these are two constant. Now find velocity at t is equal to 0 second, at t is equal to 2 seconds. So number one part is very simple one. Number one part, okay. Find velocity at t is equal to 0 at t. So we have x is equal to a plus v t square, and from differentiation, if you follow my class, then there I discussed that velocity is nothing but differentiation of x with respect to t. That means ddt of x or dx dt. That means ddt of a plus v t square. Okay. So ddt of first term a plus ddt of b t square. Since a is a constant and differentiation of constant with respect to time is 0, because constant does not change with time, therefore differentiation is nothing but a rate of change. And for constant, we know that constant does not change with time. Therefore differentiation is of constant with respect to time is always 0. So plus second term ddt of bt square, b is a constant, so b taking out from the differentiation, ddt of only t square, and we have formula differentiation of t square is nothing but n into x to the power n minus 1. This is the formula. Here n is 2, so formula is n into x to the power n minus 1. So this is nothing but 2bt. This is our velocity, 2bt. Okay, this is our velocity. Let's clear this portion. This is our velocity. Okay, now here v is nothing but what is b? B is nothing but b is given. B is maybe 10 meter per second square. B is what? B is our 10 meter per second square. So putting this value here, b is 10 meter per second square. So 2. Therefore this is nothing but 2 into 10 into t, that means 20 t. Now you have to find out the velocity at t is equal to 2 second, and velocity at t is equal to 0 second. Velocity at t is equal to 0 second. So putting at t is equal to 0, v is nothing but 20 into 0. That means 0 meter per second. This is one answer. And at t is equal to how much? At t is equal to 2 second. At t is equal to 2 second. Velocity is nothing but 20 into 2. That is equal to 40 meter per second. So this is the answer. First answer. At t is 0 and t is 2 is we have just calculate. The velocity at t is equal to 0 and t is equal to 2 second. T is equal to 0 second, velocity is 0 meter per second, and t is equal to 2 second, velocity is 40 meter per second. It's a very simple one. The next one is a very conceptual one. You have to understand the next one. There in the next one we have to find out the average velocity between time t is equal to 2 second to 4 second. Okay. So we have the average velocity. We have the formula. Average velocity is nothing but displacement by time. Okay. So at t is equal to t1. Say t1 is equal to 2 second. What is our displacement? A plus bt square. So position is a plus bt square. At t is equal to 2 second, position is called x1. x1 is a plus bt square. A is 5, b is 10, t square means 2 square. This is 2 to the 4 40 45. Okay, 45 meter. So this is our 45 meter, and at t is equal to 2 is equal to 4 second. What is our position? Nothing but a plus bt square. Now putting a is 5, a is 5, b is nothing but 10 into 4 square. So this is 165. Okay, 165 meter. Okay, so at t is equal to 2 second, position is 45 meter. At t is equal to 4 second, position is 165 meter. Like this, if it is x equal to 0, at t is equal to 2 second, position is 45 meter. At t is equal to 4 second, position is 165 meters. So between t is 2 to 4, particle moves this distance. So therefore delta x is nothing but x2 minus x1. What is x2? 165. What is x1? x1 is nothing but this 45. So 45, that is what? That is 120 meter. And 120 meter moves in time. Delta t is what? 4 minus 2, that is 2 second. So average velocity is noted as this. V bar is nothing but displacement by time interval delta x by delta t, 120 by 2, that is equal to 60 meter per second. This is a very simple one. Okay, so you follow this video. From equation of motion, we can calculate the velocity expression, and that expression, in that expression, if you substitute the value of time, we directly calculate the velocity at that time. Suppose that t is equal to 0, velocity is 0. At 2, velocity is 40, 0. Okay. Now to find out the average velocity, we have to know the displacement by time interval delta x by delta t. So at t is equal to 1 second, t1 is equal to 2 second, its location is 45 meter, and at 4 second location is 165 meters. So you see in one dimension, this is x equal to 0, say this is one direction. At t 2 seconds, location is 45, 4 second location 165. So from 2 to 4, it moves by 120 meter. That is x1, that is x2. So this is called delta x. And what is delta x? This is x2, this is our x2, and this is our x1. And delta x is nothing but this minus this is equal to delta x. So 120 meter, time interval 2 seconds, average velocity, average noted as v bar. So v bar is nothing but delta x by delta t, and putting the value 120 by 2, and that is equal to 60 meter per second. So this is our average velocity. Okay, coming to another problem. This is a very simple one for the beginners who just try to apply calculus in one-dimensional motion. Your motion is given by x is equal to t plus a. From that equation, you see you have to prove that acceleration is equal to constant. It's a very simple one. I am just doing for the beginners. So you have x, so therefore x is equal to t plus a whole square, and this is nothing but t square plus 2ab plus b square. So nothing but t square plus 16t plus 64, that is x. Okay, then what is velocity? We have velocity is nothing but ddt of x, differentiation of x with respect to time, we get a velocity. So ddt of first term t square plus ddt of second term 16t plus ddt of third term 64, and from the formula we know that ddt of t square is another 2n into x to the power n minus 1. Here 16 taking outside since it's a constant, so ddt of t, and derivative of t you know, and this is derivative of 64 is a constant, therefore it's a 0. So this is nothing but 2t plus this is nothing, derivative of t is 1, this is value is 1, so this is 16, and this is our velocity. Now acceleration, how do you get the acceleration? Is nothing but again repeat the differentiation over v. If we perform differentiation over v, we get the you get the acceleration. If you follow my previous video on YouTube, then you can easily understand how you can calculate acceleration from the velocity, how you can calculate velocity from the from displacement. These things are done there elaborately. So for your understanding, you please watch my earlier video on differentiation and integration. Okay. So A is nothing but ddt of v. So ddt of v is nothing but 2t plus ddt of 16. That 16 is a constant. So 2 taking outside, only ddt of t plus, since 16 is constant, so this much equal to 0. This thing is equal to 0. Second term is equal to 0. And ddt of t is nothing but this nothing but 1, so 2 into 1, so this is equal to 2. So acceleration now becomes only 2 meter per second square, and it is independent of time. It's a constant, this is a constant, so that means acceleration is now become constant. Okay, keep watching. I will upload many more videos on one-dimensional motions, applied mechanics. Okay, to get the videos directly, you have to subscribe my channel. So please subscribe my channel, and if you like, then share within your friends. Okay, till then, bye.